Okay. Now students, let us have a look at the first problem on straight lines. Okay. The problem is draw a quadrilateral in the Cartesian plane whose vertices are -4, 5, 0, 7, 5 minus 5, -4 minus 2, and also find its area. Okay. So let us draw these vertices, and later on we will give names to these vertices. Okay. Names means labels. We'll associate A, B, C, D to it. Right. Now the first vertex is -4, 5. -4 means x is negative and y is positive. So x is negative means we are here, right? And y is positive means we are here, right? So x is negative, y is positive. So that means we are in the second quadrant. So this is we are in second quadrant, right? This is in the first quadrant. First quadrant in the sense it is on the actually in the y-axis. It is on the y-axis because x coordinate is 0. So -4, 5. So that is the y-axis. This is x positive, y negative. So this is the fourth quadrant, and this is the third quadrant. Right? Now we are going to arrange them according to the quadrants. Okay? So the point on y-axis will be called A. So this is a point on y-axis. This point will be called A, whose coordinates are 0, 7. Okay? Then second quadrant point is -4, 5. -4, 5 means -4, that is x coordinate is -4. So let us have x coordinate here -4. And y coordinate is 5. And this is 7. So it is little below that, right? So this will be the point, right? So that point will be called -4, 5. Correct? Let us call this point as B. Okay. Now, third quadrant, it is -4, -2. So -4, -2. So -4 is same here. Only thing is -4 and -2. So it is somewhere here. So that means -4, -2. So the point will be here somewhere. So -4, -2 means the point distance will be half. So this point will be -4, -2. Right? So this is the point, let us say, this point, let us call it C. Okay. Now, the last point is 5, -5. So x coordinate is 5, somewhere here, and y coordinate is -5, so somewhere here, right? So this is the point D. Okay. D has a coordinates 5, -5. Correct. So now, if I join these points, this point and this point, okay, then from here it is this point, okay, and this one, okay. So this is a quadrilateral. Now this quadrilateral, we have already drawn this quadrilateral. Now this quadrilateral, we want to find its area. So while finding out area, there is a very simple method. The method is right. First of all, you write A, then you write B, then you write C, then you write D, and then you again write A. Remember, while writing them, you have to follow a particular order. There are two kinds of orders, clockwise and anti-clockwise. So I have been following anti-clockwise, A, B, C, and D. This is C and this is D, right? So this is the order I am following, anti-clockwise, okay? So A has coordinates what? 0, 7. So that is 0, 7, okay? Now B has coordinates what? -4, 6. -4, 6. C has coordinates what? -4, -4, -2. D has coordinates what? 5, -5. 5, -5. And A is repeated, so it is 0, 7. So let us call it like this. This is actually what? x1, y1. This is x2, y2. This is x3, y3. This is x4, y4. And this is again x1, y1. Okay. Now, in order to find the area of this quadrilateral, I have a very simple formula. I will write half here and inside there will be a mod, right? So, what I am going to do is this, that I will say I will have a combination called 1, 2. So x1, y2 minus y1, x2. So that is between these two. x1, y2 minus y1, x2 plus, now I'll take this pair, x2, y3 minus y2, x3. Okay. Now, next, I will take this pair, x3, y4 minus y3, x4, right? And lastly, it will be x4, y1 minus y4, x1, right? Now, mod of this. That is the formula for. So, it's very easy to remember this entire procedure. You just remember here, the entire first bracket contains 1, 2, 1, 2, only xy keeps on changing. After 1, 2, 2, 3, then 3, 4, then 4, 1. Okay. So, 1, 2, 2, 3, 3, 4, 4, 1, right? And you have to just repeatedly write 1, 2, 1, 2 and interchange x and y, correct? So, now in this formula, if you substitute, we'll get the desired area. So, x1 we know it is 0. So, it is 0. 0 multiplied by y2, that means 0 multiplied by 6. I'm not going to write it as 0 only. That is minus y1, 7, x2, that is minus 28. So, this becomes plus 28. Okay. Plus, now, this is x2, y3. x2, y3, that is minus 4 into minus 2. That gives you what? 8. Right? So, x2, y3 minus y1, x3. y2, x3. y2, x3 is what? Y2, x3 is 6 multiplied by minus 4, which is minus 24. So, that will be plus 24 here. Correct? Now, next term is x3, y4. So, x3, y4. So, that means minus 4 into minus 5. Minus 4 into minus 5, that is 20, right? Minus this into this. So, that will be minus 10. So, again it will be plus 10, right? And lastly, I have one more. That is x4, y1. So, x4, y1, that is 5 multiplied by x4. So, x4 is 5 and 7. So, that will be 35. Okay. And minus this into this, which is 0. Correct. Now, if you add all this half, so that will be 28. This will be 32. This will be 30. And this will be 35. Correct? Which means this is equal to half. So, this total will be what? 0 and 6. Correct? Because 8 plus 2 is 10, 0, carried 1. So, this will be 3 plus 2 plus 1, 5. 5 plus this will be 65. Correct? Finally, the answer is half multiplied by 125. Correct? So, this will be the answer. Because it is positive number, it will be 125. So, it is half multiplied by 125. That is the answer. Okay? Now, let us look at the second problem. The second problem is the base of an equilateral triangle which side 2A lies along y-axis. The base of an equilateral triangle of side 2A lies along y-axis such that midpoint of the base is the origin. Find vertices of the triangle. See? So, this is the y-axis. This is x-axis. And 2A is the length of its base. So, suppose I call the base to be A, B, there and midpoint is origin itself. That means this length, this is origin, right? So, this length is A, right? And this length is also A, so that the distance, total distance AB is 2A. Okay. Now, we want to draw an equilateral triangle with this as a base. Now, if this is a base, then this angle has to be 60 degrees, right? So, this angle has to be 60 degrees. So, therefore, there from there is a 60 degrees, it will come here. Because it is an equilateral triangle, right? So, therefore, what will happen is, this is the diagram of that triangle, okay? So, this is 60 and this is what? 90, right? 60. So, therefore, this will be equal to 30 degrees, okay? So which means this is a 30, 60, 90 triangle. And the property of 30, 60, 90 triangle is that the line opposite hypotenuse, that is the hypotenuse, is half of this side. So that means this side will be what? 30, 60, 90. So the line opposite 30 is A unit. So therefore, this side will be what? This is A, and what will be this? This will be also what? This will be equal to A uh, tan 30. So that will be tan 30, tan of 30 degrees. Okay, tan of 30 degrees is 1 upon root 3. Yeah, so the angle opposite, the line opposite 30 degrees is half of the hypotenuse. That means hypotenuse has to be 2A. So this hypotenuse has to be 2A, right? So each is 2A, 2A. Anyway, this triangle is equilateral. Therefore, it is 2A. Okay, fine. So what are the coordinates of this point? So this is not, so that means this is 2A, this is A. So it's a right angle triangle. So if I want to find out a OC, right? So then OC is always equal to under root. OC is always equal to under root AC square minus OA square. That is nothing but law of Pythagoras. Okay. So AC square, we already know AC square is OA, is 2A. So therefore 2A square minus OA, which is A square. Correct? So that means this will be 4A square minus A square, which is equal to 3A square. Therefore, the answer is A root 3. Correct? So C will have coordinates A root 3, comma 0. A will have coordinates 0, comma A, and B will have coordinates 0, comma minus A. These are the coordinates of the equilateral triangle. Okay? So this is A, this is A, this is B, this is C. That is the answer. Okay? Fine. Let's go to the next problem. Now there is another problem. Find the distance between the points P, x1, y1 and x2, y2 if PQ is parallel to y-axis and PQ is parallel to x-axis. There are two cases. So let us take first case, case number 1. PQ is parallel to y-axis. First case is this. That means if I draw, it is like this. Here is P and here is Q, because PQ is parallel to y-axis. So it is like this. So this P will have coordinates x1, y1 and Q will have coordinates x2, y2. Because PQ is parallel to y-axis, this distance will not change at all, right? So what will change is only the distance between the y-axis. So distance between PQ here, in this case, PQ, the distance PQ, right, is nothing but difference between their y coordinates. So this will be the total y coordinate minus this. So this will be the distance. So it will be nothing but y1 minus y2. Correct? So that is the distance between P and Q. Okay? Of course, we do not know which one is bigger. So we'll call it mod. So mod of y1 minus y2 will be parallel distance between PQ if it is parallel to y-axis. Okay. Now let us solve the second problem, that is PQ, and PQ is parallel to x-axis. So let us draw first of all. This is y-axis, this is x-axis, and point P, and here is point Q, because they have given that P x1 y1 and Q x2 y2. These 2 points are now parallel. So the line joining P and Q is parallel to what? X-axis. That means this coordinate will not change at all. X or y coordinate will always remain same. So but this distance is x1, right? Whereas this distance is x2, right? And I want to find out distance between these 2 points, which happens to be this much. So that will be x2 minus x1, right? But we have chosen x1, y1 and x2, y2 arbitrarily. It is not given that x1 is greater than x2 or y1 is greater than y2. So therefore, and distance is always positive. Therefore, now the distance PQ is always positive part of x2 minus x1. So mod of x2 minus x1, that is the answer to the second question. Okay. So that is the answer to the second question. Do you know? So that's how this problem is solved. Okay. Okay. Now see, very interesting problem. Find a point on x-axis which is equidistant from the point 7, 6 and 3, 4. Okay. So find the point on x-axis. Okay. Now these are the points 7, 6. So x coordinate is 7, right? So let us put it here 7, 0, and y coordinate is 6. So it's somewhere here. So 0, 6. So the point actually is the point of intersection of these two lines. So this point is A. That A has coordinates 7, 6. Okay. Now there is a second point called 3, 4. So x coordinate is 3. So somewhere here 3, and y coordinate is 4. So it will be here. So 0, 4. This is what? 3, 0. Okay. So the combination of these two. So there this point will be called B, and this B has coordinates 3, 4. Okay. So 3, 4. Now we want to find a point on x-axis which is equidistant from these 2 points. So this is one point and this is second point. Let us join them. Okay. So this is the line AB. Now we want to find out a point which is equidistant from 2 points. So always remember one thing, that if there are 2 points, then the perpendicular bisector of this line segment has a property that every point on this line is equidistant from A and B. Every point on this line is equidistant from A and B. So this property we have to use. So, but this is a perpendicular, and this perpendicular passes through the midpoint of AB, correct? So the midpoint of AB, here we can immediately find out what is the midpoint of AB. So midpoint of AB. Midpoint of AB is what? Is 7 plus 3 divided by 2, 6 plus 4 divided by 2. Correct? That gives you what? 7 plus 3, 10 upon 2 is what? 5. Again 10 upon 2 is what? 5. Therefore, the point is 5, 5. So 5, 5 is the midpoint, right? Now I want a point on x-axis. So I will have to draw a line which is perpendicular to AB like this. And this line has a property that every point on this will be equidistant from A and B, correct? So therefore this distance will be always equal to what? This distance, right? So that point I want to find out. So in order to find that point, I will have to find out the slope of this perpendicular line. Now I will erase this because not required. Okay. So this is the midpoint of AB we already found out. So we want a point which is equidistant from these two. Okay. So how it can be done? Very simple. We know slope of AB, correct? So slope of AB. What is slope of AB? It is the formula is what? Y2 minus Y1 upon X2 minus X1, which is equal to what? 6 minus 4 divided by 7 minus 3. So therefore it is 2 upon 4. So the slope of AB is half. So that is the slope of this line AB, correct? So the line which is perpendicular to it has a property that it is a negative reciprocal of this, right? So therefore, slope of this line, let us call it CM, right? So slope of CM perpendicular to AB is nothing but minus 2. Why? Because it is always negative reciprocal, or product of these two is minus 1, correct? Therefore, slope of CM is minus 2, correct? So slope of CM is -2 and the CM passes through the point M. Therefore, we'll use the formula y minus y1 is equal to m into x minus x1. I hope you remember this formula. This is called a slope point form. So the point is 5, 5. So y minus 5 is equal to -2 into x minus 5. Correct? So y minus 5 is equal to -2x plus 10. Right? So it is 2x plus y is equal to 15. So that is the equation of this line. So equation of this line CM is this: 2x plus y is equal to 15. Now this point we want to find out which is the point of intersection of this line and x-axis. Now every point on x-axis has a y-coordinate 0. So we'll put y-coordinate 0 here so that this will become 2x plus 0 is equal to 15, which gives me x is equal to 15 divided by 2 or 7.5. Coordinates of these points are 7.5, comma, okay, 7.5, comma 0. That's the end of it, okay. The next question is, find the slope of a line which passes through origin and midpoint of the line segment joining 0, 4 and 8, 0. Okay. So, find the slope of a line which passes through origin. Now, look at these 2 points. They are specific points. They got one quality that one of the coordinates all among them is 0. That means the points are lying on axis. So, P 0, 4 is lying on y-axis because x coordinate is 0. So, it will be somewhere here. So, it is 0, 4. So, this is one point. Okay. And the next point is 8, 0, which definitely lies on x-axis. So, it is 8, 0. Correct? So, these are the 2 points. And find the slope of the line which passes through origin and midpoint of these 2. So, if you join this, right, and if you find a midpoint, the midpoint will be 0 plus 8 divided by 2, 4 plus 0 divided by 2. That will give you 8 upon 2, 4 and 4 upon 2, 2. Correct? So, this is the midpoint of A, points P and B. So, it is P, this is called P and this is called B. So, midpoint of is not given any name, so we'll call it M. So now I want to find out slope of a line which passes through origin and midpoint. So, this is origin, this is the midpoint. So, I want to find out slope of this line. Okay. But that is very easy because I know coordinates of 0 or origin are what? 0, 0. And coordinates of this, so slope is given by what? Slope of OM is nothing but 2 minus 0 upon 4 minus 0, which is equal to half. Correct? Why? Because it is y2 minus y1 upon x2 minus x1. That is a simple formula. Okay? So that is how you can calculate the slope of this line. Okay?